The topic is double integrals over general region. So let's do this example. Evaluate the double integral over the region D of 7x sine of y squared dA, where D is the region in the first quadrant bounded by x equals 0. Right here, x equals 0, y equal 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. So here we go with y equal 9 right here, and y equal x squared. So how do we graph y equal x squared? Since we need y equal 9, let me write it here. When y is equal 9, x will be minus or plus 3, but since we're in the first quadrant, we want x to be equal 3. So x equal 3, y equal 9. So I'm gonna draw parabola, right? And we want it, so the region will be between y equal 9, x equals 0, and so it's gonna be this region D. Alright, so how do we do that? Let's try type 1. So to use type 1, we want the x to go between A and B, right? From here to here. So x will go from 0 to 3. So let's call whatever we're looking for 1, that double integral. So we want the x to go from 0 to 3. So therefore we want the y to go, to cover this region, we want the y to go from y equal x squared to that line y equal to 9. And that would be 7x sine of y squared, and of course we need to have a dy dx. So dy first, then dx. So in other words, we need to calculate this integral. Okay, now we're trying to do this integral 7x sine of y squared. So I know 7x is a constant, we're not worried about it. But the problem to do the integral of sine of y squared, we're missing a y here. If we had a y, then we don't have a problem, because remember, to use substitution, you want the u to be equal y squared. So you want the du to be equal to y dy. So we need this y. So in other words, there is no elementary antiderivative for sine of y squared. So what we do, we have only another option is use type 2. Alright, so for type 2, what do we want? We want the y to go, see, y to go from C to D. Remember, the outer integral, the limit of integration has to go from a number to a number always. So this has to be a number to a number. So of course it's C to D. So in our case, it will go, the y goes from 0 to y equal 9. So y goes from 0 to 9, right? So we're doing this. And then the x goes from a number, from a function to another function of y. So it's going to always go, if you notice, from h1, the graph, the function on the left side, to the function on the right side. It's a graph on the right side. So in this case, we're going from here to there. So this will be what? That would be x equals 0. And this will be x equal what? If you solve for x, you'll get x equal minus plus square root of y. But since we're in the first quadrant, so x equals square root of y. Right? Let me just do it here so I can explain it really quick. This is why the graph of y equal x squared. If we solve for x, we'll get minus square root of y, or x equals square root of y. So this part right here, x positive, right? If you take this, x is positive, so this is going to be x equal square root of y, and this part right here, this will be x equal minus square root of y, because x here is negative. Alright, so that would be square root of y, and then 7x sine of y squared. Now it's dx, then dy. Now let's try to do the integral, the inner integral. Now we don't have a problem. Why? Because sine of y squared, take an integral with respect to x, sine of y squared is constant, so nothing happened to it. An integral of 7x will be what? 7x squared over 2. Alright, and then we want all of this between 0 and square root of y, and then integral from 0 to 9 dy. Now I gotta plug square root of y wherever I see x. This is gonna be equal, going from 0 to 9, 7 over 2x squares. So oops, we need to plug square root of y there. So let me do this. Square root of y squared, right, minus square root of 0 is just 0. So don't forget sine of y squared dy. Now this is going to be equal integral from 0 to 9, 7 over 2, square root of y squared is y, sine of y squared dy. I mean, here it is a little trick. I can do this without substitution fast. So this is same thing as 7 over 2 integral from 0 to 9 y sine of y squared dy. If I call this a u, derivative of a u of y squared is 2y, so I need a 2y, and I'm going to divide it by 2, same thing. So this is going to be equal 7 over 4. This is sine of u, and this part is a du, which is integral of sine of u du is a minus cosine of u. So minus cosine of y squared between 0 and 9. So this is going to be equal 7 over 4. That would be minus cosine of 91. Minus minus will be plus cosine of 0, which is equal to 7 over 4. Cosine of 0 is 1 minus cosine of 91. And that's it for this problem.